All right. Good morning, everybody. How's everybody doing?
Great.
Right.
Great.
It's a pleasure for me to welcome all of you for this event at Automate. I'm pretty excited to have all experience what we are actually going to talk about in terms of the digital transformation and how we have a role to play in terms of being able to combine the real and digital, and how do we bring about that with the foundational elements of digital twins, IoT, and data, and foundationally bringing it all together in terms of leveraging it using AI. And we experience this manufacturing renaissance that's playing out today, and we want to make sure that each of you have an opportunity to understand how this plays out in terms of your own ecosystem and understand how this can be leveraged in the context of how you run your operations today. So what I wanted to set the context with was understanding what takes you towards an autonomous production and what are the realities that we are faced with today. Now, data and AI have been out there for a long time, and I think we have not seen these challenges as far as how you're actually driving towards the aspiration that how do I leverage the data and how do I leverage it using this in a meaningful way. So that is something which majority of the organizations are challenged. We have a large part of what we are trying to get leveraging using this overall scope of workforce and the ability for them to comprehend the volumes of data and how you're actually optimizing that as well. The other challenge that you're facing is in terms of being able to make some meaningful decisions with all the data that you're collecting and how you're actually meaningfully using it. And finally, when we come talking about manufacturing effectively and being able to execute effectively, so the efficiency and the effectiveness, and that's something we'll touch upon when we have the panel, because I want to reflect on the innovation on one side, but also the implementation or execution, because that's an area where I've spent a lot of time myself being there. So the real question is, are you ready, or what does it take to be ready, and how do you leverage the two fundamental tenets of data, which is exploding, and AI, which has become a lot more accessible for you in terms of how you're looking at it. So in terms of what is playing out as we speak, you hear a lot about an explosion of data. Everybody is now looking at not just collecting data, but having the ability to make that data of something of quality. So how do I meaningfully mine into the data? The world has never seen an excitement about AI than what we experienced over the last year or year and a half with ChatGPT. And now it has almost become mainstream in terms of how you are actually looking at getting information, the whole paradigm of a machine talking to you versus you talking to the machine. And that is so real. And I'm sure we'll kind of touch upon a few of those as we speak. But I think the key is the last one. Why are we still challenged to get value out of AI and how close we are to it? So talking about execution and talking about what value we get, I want to try and use this as a backdrop to put some context to what exactly are we talking about doing. So traditionally, what we see is you have these data coming in from disparate sources, you're bringing it into distinct applications and getting some level of insight. But what is really missing is your ability to put all this data in context, which means that you need to be able to not just have the information, but have the ability to contextualize it and then make this data, you democratize this data through applications, which we will talk about a little bit, which is what gives the power in the hands of people who are operators, people who are maintenance folks, who really have the ability to make your operations more efficient. So what is foundational to what we believe this transformation to come about is, how do I ensure that I have the empowering way of flowing the data across the organization, taking it all the way from the manufacturing process, taking it through the process and the production planning as well as validation. And we are going to spend a little time on the back end of this whole thing, which is where we're talking about production execution and production optimization, because that's where the AI has a big role to play. And we kind of touch upon it both in terms of where technology is, but more importantly, what's been the customer experience as well. I'm sure a lot of you have heard about continuous improvement as being a part and parcel of every plant and how the operations are run. But what is key is foundationally we have leveraged things like a plan, do, act, check. You're trying to do a PDCA cycle, which is more of an iterative continuous improvement. But when you talk about Lean Six Sigma approach, then we are talking about bringing in a more structured framework, which is a data-driven analysis to bring a DMAIC methodology where you define, measure, you have the ability to analyze, use that analysis and take it to the realm of improvement, and then now you can actually do the control. So it is important to understand why this is so crucial to leverage data and AI in a meaningful way. So let's walk through this because I think it's important to understand how AI has a role to play today and how do we leverage the LLMs and the ChatGPT and the other technology which is out there, giving power into the hands of people who are operators and maintenance folks. So it all starts with you cannot improve something that you do not measure, right? So you have to start with measuring, and you need to know what you have to measure. And one of the things that is important while you're trying to measure is to understand data by itself doesn't necessarily add value. Data becomes valuable when you put it in context and you have the ability to comprehend it in a holistic way rather than looking at it at a machine level or a cell level, for example. So the key is for continuous improvement, I need to have my data available in a framework that can bring in the machine time series data, bring it in context with the manufacturing operations management data, which is about your process, product, operation, and the resources that go into it. So what is key as foundation is the ability to look at the data, not just from a data from the machine, but bringing in context and marry these two and provide that data for applications which can actually provide those outcomes leveraging the latest and greatest technology we are talking about, which is AI and GenAI, for example. So this whole ecosystem is foundational for delivering value or democratizing it into the hands of people who are running operations or who are at the plant. So let's talk about something in a very simple framework. What you're looking at is how do I impact some of the key metrics that are associated with how operations are run in a plant. And when you look at it from the two large domains, you're bringing about the transparency. So it's important that you understand how I'm running, going back to my comment about you cannot improve something that you do not measure. So you measure something like an overall equipment effectiveness, which is a function of availability, performance, quality, and bring about operational transparency. But I think it's also important in this world to be able to do it in a sustainable way. Now, the ability to do all this using applications, which are applications that are what I call delivering value quickly and being able to deliver value at scale. Now, this is more in the realm of what we do when we are talking about doing analysis. Now, when we take it into the next realm around operational, the energy transparency, I think it's important to know while I'm running my operations, when I'm running my machines, when I run a line or run the plant, how effectively am I leveraging the energy, be it in terms of cost considerations, be it in terms of your carbon footprint considerations, or even in terms of how you're actually driving your overall effectiveness as far as transparency around it is concerned. Now, once you have this framework in place, the key is going to be how do I put some of these on steroids as far as trying to make much more out of the data and the contextual environment and take it to the realm of improve, which is what the AI and Gen AI has a huge potential. Now, how do we take that and make it available in the hands of people who really are the ones who decide how a production is run efficiently? So we are talking about copilots, and you will see a huge discussion in our booth area where we talk about it. But I think the context is being able to bring all this data and being able to meaningfully bring it into the realm of information which is out there related to your production operations, and having all this information help different personas, be it an operator, be it a maintenance person, not just understand what is going on, but they have the ability to now do a root cause analysis of what they're seeing. So it's an error code. What is really going on? How do I ensure that this is something that I have an ability to go and address and then institutionalize that as part of my process? So let's see quickly some of this in action in terms of how actually this plays out. So you're looking at an example of a production copilot where you are seeing how the machine is running. So it's a visual representation of a line where you have the ability to look at how the performance is. And when a specific error code comes, you have a copilot using natural language processing way of interaction where somebody can actually interact with the error. So we talk about workforce upskilling being a huge challenge or a constraint for us to address. And being able to go and look at this information and getting not just what it is, but also understanding it in the context of how and where this is playing out and how it actually has a role to play. We're also talking about being able to leverage AI. So there are a lot of organizations who have a lot of skills or a lot of expertise developed in AI too, which we want to make sure that we have the ability to leverage and use for things like quality prediction, where you need to have the quality data, you need to have AI models built around your process, and that becomes the basis for how you actually leverage that. And finally, just another example, and we'll talk a little bit about that when we have the panel, is in terms of how generative AI and AI becomes a part of something that hurts the plant operations the most when it comes to uptime or asset utilization and asset optimization. So this is an example where you are leveraging an AI-based predictive maintenance solution which can actually look into the performance, past performance and the ongoing performance of the asset and use that to extrapolate what exactly is actually contributing to the asset's health over time and being able to predict it, but use an AI system which has a GenAI copilot integrated into it to interrogate and get more information associated with that. Now, those are some quick examples of how AI is being leveraged, but what we wanted to leverage is bring it all together in a framework where we can now use these insights to not only visualize what is going on, but also have the ability to provide this visualization or the insight for people to actually engage in action this overall. So overall, from a continuous improvement point of view, we talked about data, we're talking about bringing it contextually, making sure that data is delivered in a framework where applications can leverage it, and that becomes the basis for how we can actually enable the DMAIC framework, leveraging your existing data, your existing process, and I think the key point is making sure that we can meet every customer or every context the customer brings to where they are and implement a continuous improvement framework around it as they make improvement. But the key is the marrying of the data along with AI and how that's leveraged. So I thought it would be useful to set a context for our discussion today. So at this point, I'd like to invite Steve Minier and Chris Liu Steve has been part of the effort that we have been through, and I thought it would be nice going back to the comment I made about innovation and making sure that we have the ability to understand what's the reality that's playing out. Because it's one thing to talk about all this technology being there, but how exactly is this technology being leveraged? So please take your seats.
All right.
All right.
Hello, everybody.
Yeah. I like to use this. This is a quote that our MD Del Costi talks about, and I can't tell you how insightful this is. When we talk about technology with purpose and making sure that the technology gets adopted by customers when it is relevant for something that you want to do. Because there is so much of technology that you'll see in the shop floor, and I thought it would be nice to juxtapose the experience of how a customer is embracing it, what are the challenges, what are the learnings, and how we want to go about it. So Steve, why don't I pose the first question. What exactly are the challenges that you see while we start off on this journey like this, and just help the audience kind of reflect on how this plays out?
Yeah, I think these are the ones I'm going to talk about. I think are going to be common in most companies, and definitely ones we ran into. First is just the infrastructure and getting a brownfield location connected, whether it's the plant for power meters or individual equipment. You got different controllers, PLCs, and that type of thing. So that's the big challenge. The other one is our operating model within BorgWarner. We are very decentralized, so the plants, make the decisions. They know what they want. We're not real good at, canvassing those across all the other plants. So depending on the project, and we'll talk about one later where one went kind of a centralized approach and another one was a decentralized, but your operating model is very important. And then of course, I think most companies are very focused on ROI, especially with a kind of a nebulous thing of information that's going to be used to help you make improvements. So you got to really understand the data to be able to make the ROI hit your company hurdles.
Okay, that's great. So you have some of the organizational systems and processes coming in the way, but let's also talk about the reality of how data is. So Chris, you have interacted a lot with customers and trying to see what's their best opportunity to embrace technology. I think we have appreciation for technology, but I think we have some big challenges to embrace it. So what do you see about the technology and how, what's the landscape today and how it can transform?
Of course, thanks, Francis. Yeah, so nowadays everybody's talking about, digital transformation, Industry 4.0, but down to the earth, what exactly is digital transformation? Does anybody know the answer? What it's all about? It's not just about applying amazing technologies, right? Bringing your efficiency. Down to the earth, the key value of achieving digital transformation is to be able to use the data. So meaning you start from connecting, to the existing machines, like Steve earlier mentioned, brownfield connectivity. You have to be able to connect to all different assets within your plant on your shop floor, to your IT, OT systems. You have to be able to connect to all the physical assets. Could be a machine, could be sensors, it could be controllers running in your production line, controlling your processes. But you will also need to be able to connect directly to the virtual assets, meaning it could be your IT systems, your MES, your ERP, your MOM systems, everything, right? And then once you get access to those systems, you can make your data accessible. But then you have a big chunk of this raw data, and you can't make sense of those data. And this is why you can apply GenAI, you can apply our industrial copilot for operations, those amazing technologies to help you to contextualize, to structure your data, make your data structured, so then you can run different software applications to reuse those structured data, those assets. So at Siemens, we also offer this industrial information hub, which directly runs on our industrial device. So really bring those data capabilities, data analytics, data contextualization from where it used to be. It used to be in the IT, on the IT side. It used to be done by the IT experts, data analysts. But now we bring that even closer to the shop floor. So the OT engineers, they can basically apply this application as a Docker container. So directly on the edge device, on premise. And you can basically fetch all different kinds of data that you collected from different data sources into this industrial information hub to create your own data model and synchronize piece of data or the entire data model from the edge device to the other edge device, which could be running on different machine cells or different systems, because you can also deploy edge at the AT level next to the machine, but you can also deploy the edge device as a virtual asset in your IT centralized server. So you get the full flexibility of using data, connecting data, and reuse all the structured data. And on top of it, these are just different use cases. We talked about using OEE, using dashboards to increase your machine availability, to see the full transparency. But you can even bring your own applications. And this is where edge computing with AI, this is where it actually shines. You can actually bring your own AI model, and you can execute the AI model directly on the edge device in your shop floor. So you don't really have to send all the raw data to the IT and let the data experts, or maybe it could be an external company, to analyze your data. You have the full control of your data, and you get to control and you get to use those data directly in your plant.
So that's a good segue about, I'm a strong believer there's the art of the possible out there. But let's understand from how, in an organization which is going down this path, how do you actually march towards that vision? And I'd like to use the example of the digital transformation project that BorgWarner was through around the smart sustainable manufacturing. So do you want to help put a context of what it is and what was the journey like? And
Yeah, so we actually started out with a sustainability project, wanting to collect power, uh, electricity, and gas usage at all of our 70 plus sites worldwide. And we knew we needed a system that was cloud-based to connect those two, and then obviously Siemens helped to help us get it connected. So the idea there was we needed it quick. We needed to be able to get it across all plants in all countries, and we needed to be able to improve the manual process we were using in the past to be able to collect that data to show improvements on our KPIs and so forth. And lastly, it had to meet I spoke about ROI, it had to meet our ROI targets for doing that, and it did, and it's proved out to be a great project for sustainability.
so I want to hit up on one area which I've had the opportunity to collaborate over the last 7, 8 years with a lot of organizations, especially when it comes to plant operations. And one of the areas that is most critical as far as how it's experienced when it comes to data and AI and bringing it all in context was how do you actually help with some of the foundational building blocks like what Chris was talking about. It's a journey. You don't necessarily jump from having no ability to comprehend data to being able to leverage edge and the entire ecosystem. So I just want to reflect on what was the key areas that you experienced some challenges and how the technology helped, but how it also served as a foundation for some of the next steps that we were looking at.
Yeah, so another part of looking for this system that we ended up getting from Siemens called Inside Hubs is not only did we want it to help us with sustainability, but also give us the platform that all plants have installed at each one of their locations that they can use other tools that Siemens offers to use on that system to make their plants run better. For instance, quality, predictive maintenance, and those type of things.
All right. So what I wanted to do is this is probably a good segue to talk about, and the quick summary around that is we had the ability to use, I like to call it the crawl, walk, run journey that you take in a digital transformation, and making sure that you put in place a foundation that serves as something that you can scale, meeting each of you or each of the plant, meeting where you are in terms of your OT landscape and how this can be leveraged. So this is a good transition point to talk about how that foundational effort that was done is actually helping with something which hurts a plant the most. A P&L for a plant is going to have a big line item that shows maintenance costs. And those are real hard costs that hit a plant. How do I use the current technology and all the innovation, all the excitement in a meaningful way? And we had an exciting journey with Steve and working with the team, and I'd like to reflect on that a little bit. So let's talk about the use case a little bit, and Steve, just help us understand what is the rationale behind taking this approach and what are the kind of focused areas we thought that we could target.
All right. Yeah, so like I said, we have this Inside Hubs at all plants. It's got other capabilities. A lot of the plants didn't even know what is offered on that Inside Hubs. So we did some promotion on that and talking to plants on what is available. And then we thought we would pick a use case to use. And I remember at the beginning I told you we're very decentralized. So the only way somebody in a global function like me can make something like that happen in a plant is to go find a plant with an issue, put this process in, show results, and we'll gain a pull. We call it a pull from the other plants. So work with a pilot plant, show their improvements, and then other plants will show interest and start pulling from there. So that's the approach we took. And we used predictive maintenance. And the reason I picked that is a local plant here in Detroit had a lot of downtime. So we thought, let's focus on that. Let's get that connected. And I didn't even know going into it had AI features in it. So I think Francis will talk about that or here in a little bit. But just that system was, it took a while to connect, like I said before, very challenging. But once you get it connected and it's running in the background, it's giving you the messages you need to make the decisions you need to ensure those type of failures in your equipment doesn't happen in the future. So that is a very strong pilot we did there.
Right. So what you're seeing is just what we call as a closed loop maintenance of connected maintenance. The beauty about this use case is we meet the customer or the plant where they are. To Steve's point, it's hard to connect to data, but once the data comes in, you are democratizing the power of AI and giving it to the hands of a maintenance operator. Not just in terms of knowing what's going on, but more importantly, how do I avert something which has a huge cost to how an organization operates? Now, there are two different ways this manifests itself. I like this analogy. I was in conversation with somebody and they brought it up. There is a situation in a house where something catches fire that requires immediate response. And there is another where you start seeing smoke coming from that room and you have a smoke detector. Now, this paradigm plays out in plants all the time. And we are talking about the ability to leverage, like what Chris was talking about, data at the edge, which can now intervene in action at levels of microseconds and seconds, versus events that play out over days and weeks, which is where the value is as much, because you are talking about very expensive downtime that you can avert by leveraging technologies like AI. So let's kind of dwell into it. So one is around what I call the real and the near real-time analytics, which is important because something catches fire, you don't want the whole thing getting burned down, but at the same time, you need to be able to know if there is smoke, there's a very likelihood that this particular machine is going to come down, and then that's going to bring the line down and potentially cause huge cost implications. Leave alone the maintenance operations, but it's lost production or lost parts. So with that as a backdrop, Steve, why don't you throw some light on a live example that kind of gives the audience an understanding of what are we really talking about here when we talk about predictive maintenance?
All right, so what you're seeing there is a graph of pressure. And this can relate to any kind of machine that uses pressure. And going back to the connectivity of this equipment, we had a challenge with this one piece of equipment, so we weren't able to get live data. We were getting a CFV file every, once a week type of thing and uploading it into the system to see what the data looked like. In the meantime, the plant's running and they're having a downtime events, and we just happened to go back and look at a downtime event and then see how the data, if we'd have had data live, maybe we'd have done something different. So this is a downtime event not using Sensei or the predictive maintenance system. So if you see all the way on the left, the real thin line is the normal minimum pressure, and the system started noticing some anomalies and the pressure continued to go up. And you can see maintenance started with the first fix there on September 18th. They didn't fix it. They went through, the 19th, the 23rd, even 3 more different fixes until they got it back to where it should be and it was running right. And that was a total of about 561 minutes of downtime. So when we went back and showed the maintenance leader the data that we have, he said, I would have done the first one. I would have changed out the, made that first change, and then I would have went right to the last one. Because all those other ones, if I did it, the pressure would continue to go up. And he saw that one at the end. That's what fixed it, so we wouldn't do those things in the middle. So we did have a live example later on with this same type of case, same type of equipment, and we were able to give him the notification or forecasting that something's going to happen. So with that, the AI side of it is it continues to learn what that equipment should be running at and anomalies that we can see, and then also we can plug in there, here's what we fixed, so the next time this happens, it'll come up to say, go right to step 5 and make that change there type of thing. So very powerful, as well as the copilot of being able to look at your manual of that piece of equipment, and it'll give you suggestions and so forth. So very strong piece of software.
So I just want to reflect on a couple of comments or discussions with the team when we were running this project, and we had the maintenance person called in, if you recall. And she sat through in it for 15 minutes, that's it. We need to have something like this because I'm running into all of these alarms and I'm really having people run around and figure out what's going on. The generative AI piece is a huge part of it because suddenly people who have less experience, expertise, familiarity, we talk about workforce upskilling in a big way. AI has a very compelling role to play, and it is real, and it is happening as we speak. And I think this was the case with the maintenance staff that we visited at another plant too when they saw it. This is something that we should be able to leverage right off the bat and how it can be. I want to reflect on one more thing. The reason I want to stay on this slide is you see all these numbers that are there? Now, when we started looking at how this, the value of what you're trying to solve is a definition of how badly it hurts you, right? So the question was, do I really know how much it is hurting? So you have an accounting way of how you cost a per minute, per hour downtime of a plant in the context of running a line. And I want to, we talked about digital twin, we talked about IoT data, we talked about AI. I wanted to share that experience of how we leveraged a digital twin representation of the line to educate ourselves as to what does it really cost for a plant when a machine is down. It's not just that one particular station that's down and the cost for the operator. So give an example of what you're doing in that space and how we arrived at some of these numbers, which builds a business case by itself.
Okay, we ran into a couple examples. The first one was just a synchronized line. You know, when one station's down, the whole line's down. So that's pretty easy. You know, most of that line's going to be down for that 561 minutes, like you saw. Another plant, their line is decoupled, so they've got 8 different sub-assemblies. Maybe 4 of them are connected, but generally there's cart movement or some kind of manual movement from one to the other. And when we were investigating downtime to help justify installing Sensei to help, the downtime just wasn't there, and that's why we designed that line. We decoupled a complex line so we could manage the downtime and not shut everything down. So I thought there has to be more downtime than what they're not showing. So we use PlantSim simulation, and just so happens this whole line is on our simulation. So we were able to get the line running on the simulation, hit one of the stations that was down, and just let it run and see minute-wise when do the other sub-assemblies shut down. So, basically on this one sub-assembly, after 70 minutes of downtime, other things start shutting down, right? So it makes sense. Anything below 70 minutes, it's just that. Anything above, it can get big, and there were some big ones, and it took total downtime probably 2 to 4 times what we were looking at, that the plant knew it was down, but it just wasn't recorded as downtime. So we've used that to help with the justification of putting Sensei on an assembly process.
Maybe I can chime in here.
Prem, please, I was about to come to you in terms of how this plays out.
Exactly. So absolutely, you can use digital twin in combination with our simulation software to validate a design of a machine or entire process. And nowadays, with our Siemens accelerator ecosystem, we are also in partnership, in collaboration with NVIDIA. You probably heard of NVIDIA Omniverse, right? So we actually combine these 2 technologies together, and it's called industrial metaverse. We really want to achieve that. You can, and above beyond the process simulation or machine simulation to validate the design, now you can even validate and train your AI models directly in the photorealistic simulation environment. And this also will save our machine builders or our end users a lot of time in the designing phase, in the validation phase. Also saves a lot of efforts and money by doing that. So also a great example is basically, before you deploy the AI models, or even like your machine design, your PLC programs, directly to the real machine, in the real world, right? You will be able to validate everything from the start of the process, from the PLC codes, all the way to your AI model. You will be able to validate in the simulation environment before there's any physical prototype or physical equipment is available. So that's also another benefit of using AI and simulation to validate.
I know I'm bouncing back and forth with the real and the digital. So I think it's important to recognize that as much as this innovation and technology sounds exciting, there is the element of realism that needs to bake in into how would you bring it into mainstream, and what are the challenges which are driven by process, resources, and time, and even culture for that matter, because the OT landscape works and behaves very differently than what we talk or what we experience today at a level of enterprise IT. What I wanted to, now that we have a recognition for some of this technology being real in terms of delivering value, what exactly is the path forward? How do you try to, what are the ways in which you can leverage it? We always talk about technology that is something that you can address with a purpose, and then being able to address something where you take it on with the speed that is relevant, and how you drive it. So when it comes to value that you want to generate, so the rapid creation of value and the ability to scale, how do you see that playing out based on the experiences we have had so far?
Yeah, so that's the challenge with decentralized, organization that we get out. I think every company's got an Industry 4.0, and we've, kind of a group or team. We've presented to them. Francis has helped us out on that. But I tell you, the belief is in the data and the improvements that are being made at plants that we are trying this out in. And again, that's how it works within our company, that we try and create a pull and get other plants going. Because the key is scaling, like Francis said, to help not only make improvements within the company, but also offset the investment even more. So it's very key to try and get it across as many plants as you can.
Yeah. So as we are getting close to this conversation, Chris, I want to get to the real and the vision and the action, as I like to call it. There is a vision that's out there. So do you believe AI is ready to deliver high-value outcomes in the context of where we see our plants in terms of their heterogeneous OT landscape and potential challenges with data silos? What's the vision that we want to drive with customers?
Absolutely. So I think GenAI is already changing, the entire industries. I can give you one example. So I often hear from my customers, right, from all the OT engineers, they have a big chunk of data in their database, in their historian. They have no clue how to use those data. And we also have some other examples, like one of the also machine operators. Their IT department, they develop a very complicated dashboards that shows OE, that shows quality, but that doesn't give him a lot of insights on what exactly he needs. So this is where industrial copilot could come into play. So you can basically load those data into the copilot, into the GenAI that Siemens we develop, and then that copilot will automatically generate your desired insights, your desired information based on your request. And you can just talk to the copilot in human language, right? So that's one example. Another technology breakthrough that we can apply to the real world. So we actually launched this virtual controller, this virtual PLC, back in 2023. And that's a really great representation of how IT technologies can really be applied into the OT environment. So the virtual controller is actually it's actually a real controller. It's not just a simulator. You can deploy the virtual controller in the virtual world, in the digital world, for example, in your simulation world, to run the PLC program, to execute and to validate the PLC programs. And once that program has been validated, you can bring that PLC programs into the real machine, deploy that exactly the same programs in real machine in the real world. So that's another good representation of how you're combining those IT/OT use cases with these amazing technologies.
That's really amazing. And being in the trenches, working with customer is really exciting to see the technology being mature and ready to do it. But we also need to acknowledge what challenges Steve and organizations like BorgWarner are having to adapt to be able to embrace these technologies. I know we are getting to the closing of this session, so thank you, Steve, and thanks
You're welcome.
for helping with this discussion. We have a few minutes to the top of the hour on this session, so I would be open to help with any questions from the audience.
Hi, thanks, Steve. BJ Kropp with Neapco Holdings. We're a tier 1 automotive supplier. You gave a maintenance example and sustainability example, Steve. In terms of dollars and dollars of improvement, what is the largest category that you're seeing real dollars of improvement of using data? Thank you.
Yeah, I tell you, we've been longest in the sustainability side, and it's all tied to our sustainability report and the KPIs that we're trying to hit. So we are driving towards those, achieving those, but we're just getting into the predictive maintenance side. So I can't really give, hey, here's the number one thing, but there's a lot of opportunity there. There's a lot of, like everybody in plants know, there's a lot of hidden downtime costs and other costs that are able to work on. So for sure, we see a big improvement with the operations we have since I attained to. It's all about getting more parts out at the end of the day, and that's what we're seeing happening. So hopefully that answered your question. Yeah.
Thank you, gentlemen. My name is Rich Motruk, Chief Operating Officer at Kymanox. We're a consulting firm in the life science industry. Pharmaceuticals have been very, very slow historically to adopt any kind of innovation. It's typically, they can get to an ROI pretty quickly to justify their investment. What their challenges are is just nobody wants to be the first to innovate because of regulatory uncertainty. So can you speak to that a little bit? I guess maybe in the context of the Copilot, you were showing a full line OEE across different sections of the line. It looked like specifically maybe around root cause analysis, an operator as a hypothetical was interacting with the Copilot through a large language model, asking questions and then getting insights back. Have you solved with any of your clients from a regulatory dealing with the FDA? I'm going to get insights back that I haven't validated. Now I'm going to just implement them without just by taking the word of the AI, the generative AI that's giving me an answer. The FDA is going to struggle with that. How do we solve that question? I guess is what I'm asking, and it's probably a difficult one to answer in this forum.
To give a 30-second answer, we are out of time. So we are talking about AI being leveraged using LLMs and leveraging concepts like a retrieval augmented generator. But I think where the answer to some of the needs you're talking about is when we talk about bringing in AI agents and orchestrating agentized AI, which is you create a workflow of bringing in the AI's outcomes and stringing that through a workflow that helps you validate it. We'll be more than happy to get more help with that question. Feel free to stop by at the Siemens booth. I know we are really out of time, but great question. And I think that's where the rubber is going to hit the road with AI. So thank you. So thanks, everyone. I appreciate your time at Automate. Enjoy the rest of the week. And we are as excited as you are. So thanks once again. Thank you, Steve.
You're
Thank
welcome.
you, Chris.
Thank you.
Yeah.
Thanks, Steve.